We are live. This is Math 60 2.3, and this is Intermediate Algebra, and we're doing slopes and rates of change. It's totally fun. It's a party. And we're going to do some more problems. So, example, find the slope of the line passing through these 2 points, 3, 4, and 5, -1. And I brought in a little grid so we can do it with triangles later, but let's go ahead. I want to approach it using the formula. So the formula for slope, and so one of the tricks I do when I'm giving lectures is sometimes I will write things over and over again so people will copy them down. So we've got the rise over the run, which is delta y over delta x. So the change in y over the change in x. How much did y change? How much did x change? Sounds like a rates of change, doesn't it? y2 minus y1 all over x2 minus x1. And in this case, I get to choose which one is 2 and which one is 1. Remember that what I have to do is make sure that the x and the y from one point match up and the x and the y from the other point match up. Let me show you what this looks like. Okay, I'm going to try not to go to Smeary Town. Let me not take you to Smeary Town. Okay. So I'll use yellow for one of them. And green is dark, sorry, and pink for the other. So I got to pick one to start with. I'm going to start with this one. I start with the y value. Now I put the y value up top, and I put the x value on the bottom. And these are my two yellow numbers. Okay. Then I subtract top and bottom the pink one. Now in this case, the y value for the pink is a -1. So I'm going to put it in parentheses so it's easier for me to understand and to parse because I've got a minus. Down below, I've got 3 minus, and then I put in the x value here, 3 minus 5. These are the pink points. See how they match up? That's what the subscripts mean here. We want the y's to match up, or sorry, the y2 and x2 to match up, the yellows, and then we want the y1 and x1s, the pinks, to match up. Up top, it's all y's. Down below, it's all x's. So it's kind of cool. It's a little grid of all the numbers and what they have in common. Okay, so we've got 4, and notice minus and -1 plus 1 all over 3 minus 5. So I get 5 on top and -2 on the bottom, or -5 halves. So just from the slope, I know that the graph looks like that. I know that the line heads downward because it's got a negative slope. Shall we double check using a graph? Yes, let's do that. Woohoo! So I have to quickly plot the points 3, 4, and 5, -1. So again, in here, I'm not going to be able to use my ruler because I did not think to glue this down. So it's not going to stick unless I hold on to it. I've got x there, y there, 1, 2, 3. Here's 3. 1, 2, 3, 4. Here's 4. So I've got the point 3, 4. That's my yellow point. Let me try to take you to Smeary Town again. And then 5, -1, 4, 5. There's 5. And -1's right there. I did the 5 right where I wanted to put the point. So let me write the 5 up here. Here's the point. I got eaten alive. Oh, that's lovely. I took you totally to Smeary Town. Sorry about that. I'll just make the world's largest point. Yay. Okay, so let us connect these lovely dots. There we go. Now let's walk. I'm going to take this point, which you can't see very well, and I'm going to walk to the right. Remember, we go to the right. and I'm going to stop here, and then I'm going to head down. Now, the fact that I head down is why we've got a negative slope, right? Because I headed down instead of up. So this direction, how many squares did I go? 1, 2. I went 2 squares. Now, coming down, be really careful because this is down at -1. So it's 1, 2, 3, 4, 5. I went down 5. So my slope, which is my rise over my run, my rise was actually a -5 because I headed down, and my run was 2. This is the back and forth. This is the top to bottom. Did we get the same answer? Woohoo! You can't see me. I'm doing a little dance. Okay, just imagine I'm flossing, doing the Running Man. Uh-huh. Oh, I look good too. Okay, so now, what does this mean? This means that for every unit increase in x, y will blah. Okay, so in other words, if x goes up by 1 unit, means that y, first off, what will happen to y? Y goes up or down? Y goes down 5/2 of a unit, or in other words, 2.5 units. So for every time x moves over 1 unit, y is going to go down 1, 2, and half of 1. Does that make sense? Let's look at the graph. If we move over 1, we go down 1, 2, and a half. We get to this little middle point right there. Then if we go over 1 again, we go halfway, 1, 2. There you go. What do you guys think? Kind of, sorta? Kind of woohoo? Okay, can I say something even more exciting? I know, what's more exciting, right? If x increases by 2 units, y will decrease, y will head down by how many units? Do, 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 do. You got it. 5 units. As x goes up 2, y goes down 5. X goes to the right 2, y goes down 5. Kinda, sorta? Okay, well, I'm going to let that gel a little bit because the slope's very important, but kind of weird, and there's a lot to memorize. So what's next? Well, what's next is comparing different lines. Whoa, we get to compare different lines? Yes, we do. First thing, how do you spell the word parallel? Well, just remember that in the middle, not at the end, but in the middle, there are parallel lines. So 2 lines which are parallel have the same slope. They go in the same direction. Perpendicular lines means that one line meets the other line in what's known as a right angle, otherwise known as 90 degrees, or if you've taken trig pi over 2. Okay, so what the heck does that mean? Well, there are a lot of interesting formulas around here. For example, if you have 2 slopes, they will be equal if they're parallel. If they're perpendicular, it gets weird. If they're perpendicular, if you multiply them together, you get a -1. Or in other words, the second slope is -1 over the first slope. Okay, that's a lot, I know. So what I want you to focus on is that when you're looking at perpendicular, there are going to be 2 rules: a perpendicular slopes, are opposite. Let's change the sign. Reciprocals. Flip it upside down. I know you're all looking at me like, what are you even talking about? We thought this was the easier part. This is the shorter video. What's going on? I want my money back. Well, you can't have it back right now because I'm in the middle of this. If your slope starts off at 1, your parallel slope is also 1. Your perpendicular slope is -1. Now, I know you're looking at that going, okay, fine. You're just throwing your hands up. You're like, that's it. I'm just changing to an art major. Stay with me. If your initial slope is 2, your parallel slope is 2. Exactly. These two will match. These will be equal every time. Parallel slopes are equal. So if that's the only thing you get, then awesome. We'll get that. Now, what is perpendicular? Well, let's look. 2 is positive, so the perpendicular has to be negative. It has to be the other sign, and you have to flip it upside down. Now, 1 upside down is 1. 2 upside down is 1/2. Okay, let's do another one. What if we start off with -3? Dun, dun, dun. Okay, the parallel slope, -3, right? These two are going to be equal. Now, what are we going to do? Opposite, reciprocal. Opposite means change the sign. So this one's -3, so the perpendicular slope will be positive. The 3 has to flip upside down, so we get 1/3. Kind of, sort of. What if I started with -5/7? Okay, the parallel slope, -5/7. What would the perpendicular slope be? Think about it. Let me give you a second. If it's -5/7, we want to change it to positive. And we want to flip it upside down, +7/5. Dun, dun, dun. Okay. What if my slope were positive 1/4? Then the parallel slope is 1/4. And the perpendicular, again, we change the sign and we flip it upside down. Oh, -4. What if my slope is 0? Then the parallel slope is 0. The perpendicular slope is, oh no, 1/0, undefined. Why? Because this is a vertical line. This is a horizontal line. Kinda, sorta. It's a lot. So remember, when you're looking for a perpendicular slope, you change the sign and then you flip the whole thing upside down. One last note. To calculate the percent grade, so this has to do with some of the word problems in the homework. Calculate the slope as a decimal, right? Because these are all in fraction form, so we'd have to rewrite them as a decimal and then convert to a percentage. So what does that mean? Well, if the slope is 1/5, let's convert that to a fraction. Or sorry, it's a fraction. Let's convert that to a decimal, which would be fine and dandy, except there it is. I was going to show you. Now, I hope that you know that 1/5 is 0.2, but if you don't, 1 divided by 5 equals 0.2. Okay. Now, I have to convert that to a decimal. So first thing, 0.20. Let me pull out that 0. I'm always allowed to add an additional 0 to the end of a decimal like that. And then that's going to be 20% because I moved the decimal point 2 spaces to make a percent. So percents are 100 times bigger than the decimal. And that's it. It's a 20% grade. That would be a terrifying mountain. Can I just say that you would not be driving down or up this unless you had a fancy car, right? A lot of times when you're on the freeway, you'll see 5 or 6% grade, and they're going to give you lots of warnings and lots of like, be careful. So 20%, it would just be, Okay, that's 2.3. You guys are awesome. We're making it through. The next section, we're going to talk about how to write lines down. Now that we've studied, we've looked at slopes, we've looked at all these other pieces. Let's put it all together with equations. You guys ready? I'm so excited. Woohoo, math on.